Now let's see the conditional logics. Basically, you get a robot to do different things depending on a specific condition. Let's go here to logic and select if then. The name tells a lot. Basically, it is saying that if a specific condition is true, then do something. Let's select these. And we have our spaces to fill and complete the instruction. All possible parameters are here. I want to start it like this for us quickly. Here we can see the structure. Yes, here we can see the condition. And if this condition is true, or this logic operation is true, note that I have a field here to insert code, similar to the one I have above. So this is code that will be executed if the condition inserted here is true. Then the code inserted here will be executed. We can, for example, add an exit here. So let's add an exit. Okay. Now I have this exit instruction here, and I have a loop here. So I can place some movements here, more movements, and when it gets here to this line, it will check if this condition is true, and then if it is true, it will exit this loop. This is a simple way to implement a conditional loop that keeps the robot executing some specific code until certain condition is true. This is a very common application to do.
Alright, let's go now use the for loop structure. The key difference between for and the loops that we saw earlier is that loop is a continuous repetition, so it keeps the pointer stuck in that session as long as the condition remains true, which it always will since it's an infinite loop. Inside the loop you can add a condition for the robot to exit that loop, okay. Uh, but in for, we have a different working property. For example, say you want the robot to perform an action 2, 3, or 4 times, and after it does that, you tell the robot to continue its regular path or process. You might ask, can't we use a variable and increment it each time the robot performs the action, then check it if equals 3 or 4 inside a regular loop? Sure, that works, but it's not a standard approach, and for those cases, for is the much easier way to go. To use for, we go to the command menu and then select for and for block. Okay, same idea, the three dots representing the programmable actions inside the loop, and end for closing the loop. So we click here and we have the form here to fill. We need to specify a variable here to track. Let's use that variable train var that we created earlier. And here's what the comparison happens. So what I'm saying is that each interaction, so every time it runs when executing this for, it will add up 1 into this variable until the condition becomes true. So we keep adding 1 here until it reaches 5. Okay, so here we have this is an example. Okay, 1 to 5 with a step of 1. So this means that any action that plays inside here will be executed 5 times because we have train var equals to 1. So here's our train var equals to 1 to 5, and we have a step of 1. So this means that each interaction in this loop, it will increment 1 into the train var, and as long as it is smaller than 5, everything inside here will be executed. So we have a complete structure here to handle repetitive tasks without needing to compare anything or add variables manually. So this is very useful if you have a determined number of times you need to execute an action. The required standards. If the resistance is, if the higher resistance means that the electrode isn't clean. So what do? I can command the robot until the electrode is in proper condition and set it to mill continuously. Other way, you can generate an alarm that the milling process is inefficient and requires parameter adjustment. You can fine tune the milling process and everything is working, and if it's not, it will keep doing this without disrupting the process. So we check the resistance of the electrode here. If the resistance is higher than the standard you defined, for example, in the welding controller, it will run a while condition indicating the resistance isn't acceptable, and if the resistance isn't in a row, the welding controller will trigger the while loop, and it returns feedback indicating that the robot needs to go to the milling process again. So these are some options. In the for loop already, we normally we would set like we have a fixed amount of times that the robot will do something. So this is usually a more for loop type of application. When you know exactly how many times you need to know, or you need to check a variable for that, but it's a fixed uh, uh, counting of times that the robot will execute the logic. While the while loop here, you don't have a predefined amount of data. You can just adjust the logic here, and the robot will do the loop as long as the condition is true. Doesn't matter how many times it did, and you don't have to worry about breaking. So this welding example is a good example of application. And now one of the most important structures is the if-else structure. And essentially, people think that else is a standalone command, but it is not. It is part of an if command. So if there's no if command, there will be no else command. So one is linked to each other basically. Basically, else means if not. Okay, so we go to commands here. We have the if then option here. I'll click. And again, we have all the attributes we need here to create our condition. And below, we had the option to add the end, add the else, add the o, add the shore. So I can chain multiple conditions within this instruction by adding more commands down here. I will add an else here. So essentially it will add my else here. And if I click OK, you see I have a spacing between the if, the else, and the end if. And those spacing is the places where I can put my logic that will be executed depending on the specific condition. So basically what it's saying here is that if my input is 1, then it will execute this code here. Okay. So if a signal from a PLC is true, or any other input that we have is true, then it will execute this code here. Else, or if the condition is not true, it will run the other condition here. But the else is optional. You can have you don't need the else. You can have just the if and the end if. So if you want the robot to execute something in a specific condition, but you don't want to deal with the if this condition is not true, so if the condition is not true, then the robot should be executing the rest of the program normally, then you don't need an else command, okay? You just put an if. But the else is representing what happens if this condition is not true. So with the else, we can deal with both cases. If the condition is true, it will execute what is below the if statement right here, and if not, it will execute what is down there on the else command, basically. Okay, this is one of the most interesting topics, how to call other modules or routines within a single routine, within inside one routine. So, for example, if you have a main routine and we want to call our treinamento routine, how do we do this? So let me open the main here first, and the syntax should look like this. You need to write the name of the routine followed by this parenthesis. To add a thing like that, you need first to click on the pencil here to add the syntax, and then you need to type the same name as the routine. So the other routine calls treinamento, I said call treinamento here, and Since I already added it, let me remove this one. Okay. And close the edit mode. Okay. You notice that every time we make a change and close the window, it will ask to save the changes. I'll say yes, of course, and it automatically saves the modifications that we've made. Now, if I select my main routine here, you see I will place my step selection here. I will move the pointer to the training routine. You notice that this way it accesses the treinamento routine. So now we have our program pointer inside the treinamento routine. And when it will return at when it reaches the end command. It starts with always the routine starts with a def command and ends with an end command. And this end command is like a return in other programming languages. So when the routine ends, it will go back to the main routine where it was originally. All the conditions we discussed earlier, like if, switch case, and so on, it could also include a loop, like a for loop or a while loop, with switch cases. For case 1, 2, or 3, I could call a routine to execute an operation. So those are methods that we normally use for programming robots. Pro tip, this ties directly to your program's structure. Always add comments to your code to make it easier for you and others to track what each instruction does in the process. Okay. In the command menu, you find 2 options of comments available: the normal and the stamp comments. Uh, the normal lets you write basic notes. For example, pickup point, like ponto de pega, which is typed out here. So you type your comment and click OK, then click yes, and here you have your comment. Okay, it only adds this. But if I use the stamp option, you see that I have now the name, and I also have the timestamp of this comment, and I also have the name where I can put my name so people know that the modifications or this comment specifically is mine. And here in changes I can detail what I changed. So this is a very important thing. So I said name Wallison, and then what was changed was the comment, okay, or the pickup point, or the ponto de pega as it calls here. But you see that we automatically have a timestamp, we have an option to insert name and a comment. This is very useful to be used, especially to keep track of what was changed during, for example, shift changes, or you're working in a big engineering team and a lot of people work in the robots. So it's always a nice practice to keep these timestamps always updated, and always describing what exactly did you do in the code. So use it freely, and this will help a lot to increase the efficiency of your team. Okay?